The most precise machine on Earth spends its entire life sprinting. Under its light, the silicon wafer rides a stage that pulls 8G of acceleration, well beyond a fighter jet at takeoff. Above it, the stencil holding the chip's pattern sprints the opposite way at exactly 4 times that, 32G. And through all of it, the two stay synchronized to the nanometer and the nanosecond. In part 1, we watched this machine fight to keep its light alive. Now, the light works, and the machine hits a wall. At full pace, it finishes up to 185 wafers an hour, depending on the dose of light each layer needs, around the clock, for years. For a decade, this design kept shrinking the transistor's gate, its on-off switch, until it was just a couple of dozen silicon atoms long. Then it hit a wall. To go finer, chip makers began printing the same layer twice, 3 times, 4 times. Align, print, repeat. And every extra pass is one more chance to ruin a chip that's already weeks in the making. The industry didn't need more passes. It needed a sharper eye. A sharper eye needs bigger mirrors. And bigger mirrors created a problem so absurd, it sounds fake. The image no longer fit through the optics. So the engineers stole a trick from the movies. Cinemas solved this a century ago. Squeeze the picture to fit through the lens, unsqueeze it on the screen. That is exactly what the new machine does. It prints your chip squeezed, 4 times in one direction, 8 times in the other, and the mirrors unsqueeze it onto the silicon perfectly, every time. The result is called high NA EUV, the sharpest eye ever pointed at a piece of silicon. Now, let's talk about what this thing physically is. It weighs more than 150 tons. It contains over 100,000 parts. It cannot ship assembled. It leaves the factory in roughly 250 crates, filling multiple 747 class cargo freighters. And once it lands, rebuilding it takes a team of 250 engineers about 6 months. And the price tag, approximately $380 million. For one, and chip makers don't buy one. Now, the part of the story that never makes the brochure. The idea of printing with this light is older than the web. Researchers proposed it back in the 1980s. And for most of the decades since, it was the technology that was permanently 10 years away. Labs could make the light exist. Nobody could make it bright enough, stable enough, cheap enough to print chips for money. By 2012, the remaining bills had grown so extreme that the Dutch company building it did something almost unheard of. It asked its own customers to help pay for the research. And over a single summer, 3 sworn rivals, Intel in July, then TSMC, then Samsung in August, companies that spend their lives trying to bury each other, together poured more than $5 billion into the same supplier, one after another. Rivals don't do that for a product. They do that when the alternative is that progress just stops. Even then, it took 7 more years before the first chips printed with this light reached your pocket. Today, the bet has flipped completely. Nearly every leading-edge AI chip made today is printed with this light, NVIDIA's newest included. And every machine that makes this light anywhere on Earth currently comes from that one company, one supply chain, one needle's eye. The whole AI century threads through it, which brings us to this episode's impossible number, $380 million. For a machine whose only job is to draw lines. But here's the strange part. The chips coming out of it ran into a wall of their own. They grew too big to print at all. So engineers did something that sounds like sabotage. They started breaking their chips on purpose. That story is next.